CERN scientists have revealed a terrifying discovery. What can travel more quickly than light? Since ancient times, people have recognised that nothing can move faster than this speed. However, a team of researchers has successfully altered and broken the speed of light. This accomplishment has raised many questions from individuals curious about how it was done and what it means for the rest of us. Welcome back everyone. In today's video we'll be discussing how scientists recently managed to break the speed of light for the first time, among other astounding cosmic discoveries. Although sound travels very quickly, light travels much more rapidly. Light travels at an astounding speed of 299,772 458 meters per second. Many individuals aren't even aware that light travels because it happens so quickly. Consider the last time you turned on a light in the dark and immediately the room was illuminated. However, sunlight takes more than 8 minutes to reach Earth when it is produced by the sun. However, that is due to the sun's distance, which is 93 million miles. A crucial aspect of physics is the speed of light. But how could this happen? Astronomer Ole Rømer was the first genius to recognise that light has a rate. He was researching what seemed to be an odd motion of the moon around Jupiter in the late 1600s. He discovered that the giant planet occasionally obscured its little moon from our view from the Earth, resulting in an eclipse. Over the year, the intervals between the eclipses did change. After making observations for a while, Rømer discovered that the Earth was in a specific location, in its orbit around the Sun, when RU was overshadowed. However, the Earth would be slightly different by the time the next eclipse, a few days later. He concluded that since the Earth was farther away than when the previous eclipse was visible, observers would have to wait a little longer to see the eclipse since it would take much longer for the light to travel to them. The situation was the opposite when the Earth was a little nearer to Jupiter. Rømer concluded that the light moving at a finite speed was the only plausible explanation for the changes in the time of the eclipse. Rømer of course served as the tool required to measure the speed of light precisely. After him, researchers carried on with their observations until the middle of the 19th century, when physicist James Clerk Maxwell unintentionally discovered a significant discovery regarding the speed of light. As he studied electricity and magnetism, Maxwell understood that shifting electric fields could generate magnetic fields and vice versa. The physicist was astonished that the electromagnetic wave speed he had emanated matched the speed of light that physicists had seen. It demonstrated unequivocally that light speed is determined by electromagnetic waves which make up light. However, another genius would show up and completely alter the situation. Einstein said, "The scientists proved that there existed a single constant or a certain speed that could tell us how much space was equivalent to how much time and vice versa, with the help of Einstein's theory of relativity." Additionally, light from stars takes billions of years to reach us due to how wide the universe is. The light from Alpha Centauri, the nearest star to us, travels for 435 years before reaching us. Before reaching us, some starlight has been travelling for billions of years. Can anything ever go faster than light? If there is a certain speed at which it moves. According to Einstein's theory, the speed of light serves as a sort of absolute global speed cap. As a result, anything with mass cannot travel at the speed of light, since doing so would require an endless supply of energy. However, researchers from the University of Rochester in New York and Lawrence Livermore National Laboratory in California have successfully altered the speed of light waves with plasma. In the end, electromagnetism will prevail. A photon speed is maintained by the force created by the interplay of electrical and magnetic fields. The collisions between these low-frequency photon pulses result in periodic waves. The rise and fall of entire groups of light waves as they move through the matter constitute the group velocity. These scientists could slow down or streamline the delivery of light pulses by removing electrons from a stream of hydrogen and helium ions using a laser. Refraction caused by the plasma fields and polarized light from the primary laser were additional factors. Individual light waves continued to move at their usual speed while the group dance appeared to speed up. The experiment reveals more detail on the physics of plasma. Some of the most cutting-edge laser technologies can be found at Lawrence Livermore National Lab. Even though being able to travel at the speed of light has numerous advantages, such as opening up new horizons in the cosmos, this accomplishment does not indicate we are now developing spacecraft that can match the speed of light. Still, this initiative may be able to bring humanity closer to the kind of future we want. Speaking of light travelling, the James Webb Space Telescope has for the first time captured light from an extraterrestrial world, enabling it to take pictures of a faraway planet. The JWST was anticipated to be a compelling space telescope scientist. Its extravagant construction cost $10 billion, and it included numerous intricate components and technologies that allowed it to see a great distance into space. To see the Space Observatory send back the image of its first exoplanet is still a weird experience. Only a small number of these exoplanets have been directly observed. The most well-known directly discovered is HR 8799, whose 4 gigantic planets have been photographed so often that astronomers have created a film of them orbiting their home star. The JWST, however, has altered the dynamic. The HIP 65426 star, which has a large planet called HIP 65426b, was photographed using a telescope. Several years ago, the exoplanet was found using the direct imaging technique. It orbits the star approximately 92 times further from HIP 65426 than the Sun-Earth distance. That is a distance from its star of approximately 14 billion kilometers. This creates a great separation between the star in the sky and our viewpoint. Additionally, it was said to be a hot planet with cloud top temperatures of at least 1200 degrees Celsius. The planet's size and temperature are exceptionally bright for a world. The JWST features various instruments or coronagraphs that help the telescope block the light from a brilliant star to search for nearby fainter objects. Different infrared light wavelengths were used for each photograph. The planet is visible in each shot. It's a single bright pixel that has been moved away from its hidden stellar host. The pictures are not of the highest quality seen in science fiction films, but they nonetheless demonstrate that the planet was seen against the dark background of space. The scientists in charge of the observations acknowledge that they developed a new respect for JWST. The telescope is operating about 10 times more efficiently than what was anticipated. The astronomers could calculate the mass of HIP 65426b using these observations. In addition to producing photos of an exoplanet, this observation demonstrates that JWST can do in terms of exoplanets. It implies that the space telescope can observe more minor planets directly than initially anticipated. Scientists are thrilled because JWST's ability to observe smaller and fainter planets than anticipated mean there will be greater variety of each potential research candidate. In addition, the JWST's measurements were made with such accuracy that it indicates we will be able to learn much more about their atmospheres than was initially anticipated. And that's all we have for the video. Don't forget to like and share, and we'll be back soon with another informative one. We'll see you all soon.